In this project, we will learn how to control the speed of a CPU fan by getting input from the user. We will also learn about transistors and how they are applied in electronics, and will specifically incorporate an NPN transistor in our project. We will also be introduced to the serial monitor in Arduino for debugging and getting input from the user. Let's take a look at the objectives for this project. By successfully completing this project, we would have mastered the following items. You will understand what is a transistor and the different ways that a transistor can be used. You'll understand the basics of an NPN transistor. We'll also use the serial monitor in Arduino to accept input and display output. And finally, we will learn how to process input that is received from the keyboard and use that to affect our Arduino circuit. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, a CPU fan, 220 ohm resistor, an MGE182 NPN power transistor, connecting wires, and a 12-volt DC power supply. Let's first talk about a foundational component in electronics, the transistor. Transistors form the building blocks of all our modern electronic circuitry. In fact, we have gotten so good at manufacturing and miniaturizing transistors that billions, yes, billions with a B of them, can fit on a chip the size of your thumbnail. If we look at a single transistor, however, it is composed of semiconductor material and consists of three leads: a base, an emitter, and a collector. We will learn more about the operation of the transistor shortly. Transistors can be thought of as miniature switches and primarily operate in two logic states, on and off. Transistors usually have two main modes of operation. They can be used as switches to quickly switch a circuit on and off via an electrical signal. This can be controlled very accurately, up to thousands of times a second. And they can also be used to amplify signals in a circuit. In our circuit, we are primarily using the transistor as a switch to turn our motor on and off. Let's take a look in more detail about how a transistor operates. We are using an NPN bipolar junction transistor, or NPN BJT transistor for short. Another type of transistor is a PNP transistor. The difference between these two lies in the direction of the base current and how it has to be applied to turn on the transistor. For an NPN transistor, we need to apply current to the base to turn on the transistor. You can think of the operation as a switch for our motor. In order to turn our motor on via an electrical signal which we can manipulate using the Arduino, we apply an analog voltage output from a pin of the Arduino to the base of the transistor. This effectively turns the transistor on, causing the circuit to be complete, and current will now flow through our motor, turning on our fan, down to ground. The fan turns on. We are using the MGE182 NPN power transistor as it can handle higher currents and voltages passing through it. We are actually incorporating pulse width modulation as well to also control the speed of the fan. The longer the on duty cycle that is applied, the faster the fan spins. We will see this in more detail later on when we examine the code. Let's take a look at our circuit diagram for our project. This is our MJE182 NPN power transistor, and the pins labeled from left to right are the emitter, the collector is the center pin, and the base on the right hand side. So first we connect the ground pin of the Arduino to the ground rail. Then, in wiring our transistor, we connect from the emitter to ground. Our collector pin goes to the negative of the fan. The other positive pin of the fan for our CPU fan for our motor goes to VIN of the Arduino. And then finally, from pin 11 of our Arduino, we go through a 220 ohm resistor to the base or the right pin of our transistor. That is our circuit diagram. Let's go ahead and wire up our circuit. First, we're going to take a look at our transistor. The emitter is the left pin, the collector is the center pin, and the base is the right pin. So they have made it easy for you on the MGE 182. The pins are labeled, so that would help you out in wiring up the transistor. So let's go ahead and connect the transistor in our circuit. First, we will connect the ground pin on the Arduino to the ground rail. Next, we're going to connect the emitter of our transistor to ground. Then, from the base, there is a 220 ohm resistor. So we'll make that connection now. The other end of that resistor goes to pin 11 on the Arduino. Now it's time to connect our CPU fan. This is the specific fan that I have. There are a couple of connections here. There's a bigger Molex connection, and there's also a smaller connection for our pins that we may use. So I'll just use this. The black wire is the negative, and the red wire is the positive on this here. So from the collector of our resistor, we're going to go to the negative red of the fan. So that's the center pin. I'm going to go here to the black wire on the fan. And then finally, from our VIN on our Arduino, we're going to go to the positive pin of the fan. So VIN and the positive pin. Remember, the only other thing that you need to do is that you also have to connect up the DC power supply. So there, if you have a jack connector, barrel jack connector, that can go into the actual DC power supply here. We'll wait a while until we upload the code, then we'll connect that. So that's our circuit. Let's go ahead and upload the code. While the code is uploading, I'm going to open the serial monitor. So you can get to the serial monitor from this icon on the right hand side of the Arduino IDE. And in the serial monitor, if there is any serial.println commands that have been issued in your program, the text will show up in the serial monitor. And also there is an input box for sending instructions. So a user could type instructions and send this to the Arduino program. And that's essentially what we're doing. In our project, we are asking the user to enter a number between 0 and 9 to control the speed of our fan. 0 will shut the fan completely off, 9 will be the highest speed of the fan, and any number in the range between 0 and 9 will adjust the speed accordingly. So let's go ahead and send 5. So as you can see, it turns our fan on. This is about mid-speed. I'm going to increase this to 7. Right now it's spinning even faster. And then I'm going to go all the way to 9. And this is the highest speed. To shut our fan off, I'll send the 0 instruction, and as you'll see, this shuts the fan completely off. Please remember that when you connect your circuit, that you should have your DC power supply plugged in, your external DC power supply, because the Arduino by itself cannot provide the voltage and current needed to drive the fan. So you need an external power supply. So please remember that. The difference in this circuit compared to the other circuits that we've done is that we'll also need a secondary power source for the Arduino. This is because in order to drive the motor for our fan, we require a higher voltage and a higher current. You can use an external AC adapter which provides 12 volts that we connect directly to the DC jack of our Arduino to power our fan. Okay, let's delve into the code now. So in our program, at the beginning, we first define the motor pin as pin 11. Remember, that was the pin that's going to generate the pulse width modulated signal to the transistor. Next, in our setup function, we have pin mode. We're setting the motor pin as an output. And initially, we are turning the fan off. So we're doing an analog write to our motor pin. And we're sending 0. So that's going to shut the fan off. In order to communicate with the serial monitor, we have some initial setup. We do a serial begin 9600. That's the baud rate that we're going to communicate with the serial monitor on or at. And then we're going to display our instructions, serial.println, enter a number between 0 and 9. So that shows up in our serial monitor when we run our program. Next, in our loop function, basically we are polling and checking to see if the user has sent any instructions to the Arduino. So we do if serial.available. If that's the case, we're going to get input from the user. We first extract the character that the user entered. So we do a char ch equal to serial.read. We read that character in. And basically we're checking to see if that character was a number. So if it is between 0 and 9, what we'd want to do is convert that character to an integer. So we can achieve this in a clever way here by doing ch minus the 0 character, and this would convert our character that we read in into an integer, speed, and then we proceed to do an analog write to the motor pin, passing in, and here we use the map function to map our speed between 0 and 9, and we pass in between 0 to 255. So that is how we're able to do an analog write to the motor pin and adjust the speed accordingly depending on the input that came in from the user. To summarize, in this project, you learned how to accept user input to control a CPU fan. You were also introduced to a common electrical component, a transistor, and you were shown how it works. The serial monitor was introduced, and it is a handy feature for debugging and communicating with your circuit via keyboard input. We also learned how to read input from the user and use this to adjust the operation of our circuit. It was a simple project, but quite a lot of new concepts were learned here. Let's move on to part 2 of this project, where we make some slight modifications to enable our fan to be controlled via a button.